Okay. Good afternoon, everyone. How did the homework go? Do you have any questions about the assigned homework? Please, as usual, put them on chat before we start. Okay, number 7, letter F. All right, we go through that. Okay, so we look at number 7. And if anybody has any questions, please put them up. Okay. So yeah, we're doing 7 and we'll look at number 8. So number 7 is the following. We have a function, a piecewise defined function, and this function is equal to, okay, all right. So this function is minus x squared, so minus this when x is less or equal to minus 2, so under this restriction. And it's x squared, that's the rule, when my input is between minus 2 and 3. And finally, it's x when my input is bigger than 3. Okay, so that's how my function is defined. Very good. So now the question is, I will go through all of it, even though your classmate asked for F. So the first question is, what is f of 0? So I put the question and you guys put the answers on bright space or on chat. F of 0, f of 3, f of 6, and finally f of minus 3. Okay, so f of 0, so I see student writing 0. Let me see, make sure. Okay, where is 0 here? 0 is not less than minus 2. 0 is between minus 2 and 3. So the rule here is that basically it's 0 squared, which is 0. All right, f of 3. Indefined, absolutely correct. There is no output for 3. So between minus 2 and 3 is strictly less and bigger than 3. So indefined, because they did not give me an output. That's what it is. Now, f of 6. What is f of 6 in this problem? 6, do you agree with, I'm right here now, it satisfies this condition, so that's 6, it's just x. And finally, what is f of minus 3? So we have to go ask ourselves, what is minus 3? Minus 3 is right there, so it's minus the input, minus 3 squared. But minus 3 squared is minus 3 times minus 3, which is positive, which is negative 9. All right, so this is understanding really the formula. Part 2 is, I need to find the average rate of change for x between negative 2 and 4. Okay, so verbatim the formula. It's the output at 4 minus the output at minus 2 divided by 4 minus 2. And be very careful, if you put f of 4 here, this has to be a 4. So that's the first one. You put minus 2, this has to be minus 2. All right, so now we have to compute each term verbatim. 4 minus minus 2 means 4 plus 2, which gives me the 6. Now, what is f of 4? F of 4. I have to go right there. So I need f of 4. I do it on the side. So right here, what is f of 4? Okay, f of 4, it means x is equal to 4. Now f of minus 2. Okay, minus 2 is right here. It's minus 2 squared minus 4. So now I plug in everything. So f at 4 is a 4 minus f of minus 2, it's minus a 4. So now that's only give me 8 over 6. And you can simplify a little bit, which give me divided by 3. This is gonna give me 4/3. Okay, so if those got those, the student who got those answers right, it's good. Now we have to sketch the graph of f. All right. So we've never done this. No, we've done this stuff problems before, but now we're gonna do it again. So I'm gonna take another piece of paper so I can keep the function with me. So this function will consist of 3 pieces. Minus x squared for x less than minus 2, x squared between minus 2 and 3, and x for x bigger than 3. So I will rewrite it here and I graph next to it. So that's my function. It's minus x squared and x, and this is, minus 2 between minus 2 and 3, and for x bigger than 3. Okay. Now, of all those functions, the only one which is linear, it means of the form mx plus b, is this one. So this is the only one which is a line. This one and this one, those are not lines. I mean, we have an x squared. So we're going to plot several points to graph this function. So this is, okay, and we graph it piece by piece. So the first piece I want to graph is this one for x less than minus 2. So minus 2 is right there. And I want to sketch the graph up to minus 2. Now, how does the graph of minus x squared looks like? Probably some of you know it and probably some don't. So we're going to just plot points. It's not a line, so I cannot only plot 2 points. So I'm going to plot several points, x. And very soon we'll learn how this graph looks like just by looking at it. Now, the point I'm interested in has to be less than minus 2. So I cannot, right, half of a hill, right. So I cannot really, I don't want to take value bigger than minus 2. So I'm going to pick, for example, minus 4, minus 3, minus 2. And I'm going to really stop right there. All right. At minus 4, what's the output? Minus 4 squared, which is minus 16. Minus 3 squared, minus 9. Minus 2 squared, which is minus 4. Okay, and it's closed at minus 4. So let me somehow, so this is like a parabola. It's basically the graph here. If you guys remember a little bit high school, the graph is this parabola. And we're going to sketch it up to minus 2. That's really what's going to happen. So minus x squared, this graph is a parabola going down, and we're going to sketch it up to minus 2. That's really what we're going to end up doing. But we plotted points just in case you don't remember how the graph looks like. So let me plot those points. So this is minus 3, and this is minus 4. At minus 4, I am down at minus 16. That's a point. At minus 3, so this is minus 16, minus 9, so it should be somewhere in here. That's minus 9. And that's minus 4, should be somewhere in here. So the graph is going to look like that. And this point is included because x is less or equal to minus 2. So I stop right there, and this would represent the first part of the graph. So this piece is the minus x squared piece. Okay. Now, between -2 and 3, so this is 3 right here, I have another formula. I have x squared. So now I'm going to focus on graphing this piece. I only want to graph it between -2 and 3, open at -2 and open at 3. Okay, so we're going to be patient and do that also. So this is x now, and this is the x squared. And only between -2 and 3. I'm not going to take anything else. So I'm going to take, for example, -2, but I know that's open here. We keep that in mind. I'm going to take a -1, 0, 2, just to be lazy, and finally 3, and we know that it's open right here. Okay, so we graph those. At -2, I will have 4, because -2 times -2, 1. I have a 0, I have a 4, and I have a 9. So how is the graph going to look like? At -2, it's 4. That's my 4, but it is open. Okay, and then at -1, it is 1. It's down here. So at -1 here, I am at -1. At 0, I am at 0. And that's really a parabola. And then at 2, I am back at 4. And at 3, I am up here at 9, and that's open at 9. So it's going to look like that. Open here at -2, it's going to go down. That's a typical parabola. Going to go up, and right there, we have open at 3. That's how it's going to look like. So this is right there. So this one is here, and this is right there. Finally, when x is larger than 3, when x is larger than 3, that's a straight line. So again, I'm going to go right down here and graph it. Now, I'm only interested bigger than 3. I start at 3 because I want to know where I need to start, but I know that it's open here. It's 3. At 4, 4. 5, 5. So now we draw the graph. At 3, this is 3 right here. That's right there. It's open at 3. Then at 4, it is 4. At 5, it's 5. We're going to have this line. And at 3, right there, it's open here and open here because the function is not defined. Okay? Please, questions about this problem. All right. Now, what's the domain of this function? Now that we graphed it, what's the domain? Okay, now I go back to you. It means which input, for which input value, it means all the x's that have an output. What's the domain for this function? Anybody? Is there an output for every value of x or no? What's the domain? I'm listening and reading. Anybody? Okay. The domain is going to be not all real numbers. Let's think a little bit. Which value, which input we don't have an output for in this particular problem? Which input we don't have an output for? 3. Right, x can't equal to 3 because according to the definition of the function, they don't have an output at 3. That is open here and open here. There is no output at 3. It means the domain is going to be, if you give me any value of x, I can tell you what f of x is. Only at 3, I cannot tell you. So the domain is going to be all real numbers except such that x is different from 3. Everything except 3. 3 really has a problem in this particular situation. Okay, and my last question is, what is the range? It means the output value. What are the output value in this particular picture? I mean, what are the y values? I'm going to start asking you questions. All real numbers such that y is less than 4, y is less than, so this was a -4. And what else? And this was 9. Okay, so let's see if your classmate is correct. It's -3, this is -4 here, crucial, and this is a 9. And now, like, is -3 in the range? Is it an output value? No, there is no output input that goes to -3. Is -9 in the range? Yeah, you can find input that goes to -9. 3 in the range? Yeah, you can find an input that goes to 3. That's how we look at it. 9 in the range? No, because that's open right there. 10 in the range? No way. No input gives me an output of 10. So the range are all those y value that could be obtained by an x value. So it's going to be the range. All values of y that have the following properties. Either the y has to be here, so let's mark them down. This is the range. Down here, that's a range, or y has to be from here to here. This is the range. Those two form the range. So all values of y such that y strictly less than -4, it means it's right there, or y between 0 is included, and 9. So this is the range. Okay, so the range are the y values, and the domain is the x values. Okay, please, questions as we move on. It's your chance to ask me any question you want. Okay. So we're going to look at number 8, and then we proceed. Doesn't x bigger than 3 goes to infinity? Is x different from 3, not bigger? Ask your question again so I understand it. For the domain or the range? The range, everything is allowed except 3. Everything else. Okay, that's the range. The domain up to -4, sorry, the range is up to -4, and then from 0 to 9. That's how it works. Okay. Very good. Now, number 8 is a little bit harder, but we will get through it. So, but here you have to help me out because I'm tired of talking by myself. I need help. So I'll put the problem in front of us and we're going to discuss it. Okay. So what is going on here? You have a museum and it has a special pricing plan for large groups of students. So you have a museum and you want to take kids to the museum, so they have a certain plan. And the school pays $200 for a group of 20 students or less. So if you take 20 students or less, they have a flat fee of $200 for all of them. If the group has more than 20, so if you have more than 20, then in addition to the 200, the school pays $5 for each of the next 10 students. So for the first 20, 200 flat fee. After that, you pay the school will pay the 200. On the top of it, $5 for every extra student above 20 students, up to 30 students. Now, if the group has more than 30, so we have more than 30 students, in addition to the charge for the first 30, you will pay $3 for each remaining student. So let f be the function that to every number n of students, assigns the amount of money the school must pay for the group of n students. Answer the following question. So we're gonna do like a table and start answering those questions. I'll try to keep the problem in front of us and the table. So this is my table. The input, number of students. That's the input, number of students. The output is the cost to the school. The cost to the school to get any student inside the museum. And now we want this, f of 15, 21, 27, 31, 32, 37, okay? So I want you to help me out with this. I will not put the answers. I want you to help me out. All right. If 15 students go to the museum, how much will the museum charge according to the story? I want answers. 200, okay? I want all of you. I don't want one student. I love to have one student. I want more because there is a flat fee, 200 for a group of 20. So 20 or less, $200. What if we have 21 students? What's the scenario? What happened after that if the group has more than 20? So in addition to the 200, the school pays $5 for each of the next 10 students. If I have 20 down, no, read the problem again. Yeah, but what's the answer? What is f of 21? 205, right. It means 200 for the first 20 and then $5 for 21. That's how we're gonna understand it. What about 27? What's the scenario in here? So we have 7 students over 20 basically. So what's gonna be f of n? I'm reading 235, so let's see where this is coming from. It's the 200 for the first 20 plus $5 for each student above 20. It means that much, which is 235, okay? Now, if you have 31 students, I want you to think a little bit. The story tells me what if we have 31 students? What's really going on? I'll give you a minute to think through that. Okay, I absolutely 253, because what's happening here? Let's see. The question is, if the group has more than 30, in addition to the charge of the first 30 students, the school will have to pay 3 for each remaining. So it means that 3 for the 31st, but then here you have how much the school will have to pay for the first 30. But how much it has to pay for the first 30? It has to pay the 200 for the first 20. Between the 20 and 30, they are charging 5 per person. So it's give me a 250 plus 3, which give me a 253. So that's how it is working. All right, now 32. So if we have 2 students more than 30, what's gonna be the answer? 256. That's easy because 3 extra students. Now 37. So what's gonna be 37? So I have 7 students more than 30 students basically. So I'm having 271 since I didn't do the math. Okay, one way we can think about it is that 250 for 30 students, because it's the 200 plus 5 between 20 and 30 plus. For every student above 30, they are charging $3 plus 3 times 7, which will give me 271 students. Okay, so that's really how the story is. So now really the question is, can we find a formula instead of starting to do this all the time, which is okay. Can I find a formula? So by using the formula, I can pick up those answers immediately. Okay. And I asked you to graph the function before you find the formula, just to give it a little bit of, feeling for it. So if I want to graph the function f, okay, first, as usual, what should goes on the horizontal axis? Back to you. What goes, if I want to graph this function, what goes here? The number of students, everybody, always the input go on the horizontal axis. So here, n, number of students. On the vertical, the cost in dollars. So that's the cost in dollars. So how much the school will pay for those students. All right, how's the graph gonna look like? Who can a little bit help me graphing this? How would we do it? Anybody? How many pieces will this graph have? Let's start with that. How many pieces will it have? Okay, the first piece, up to 20 students. What is the scenario? The cost is fixed. Whether you have, so at 0, forget it. I'm not considering 0 student because we're assuming somebody is going to the museum. But there is a flat fee up to 20. It means whether 1 student go, or 15 go, or 19 go, the museum is asking for a flat fee of 200. Okay, so that's really a constant number here. So up to here, basically I have a flat curve right there. Okay, what after that, what happened? Between 20 and 30 students, what is really going on? Every extra student, the cost will increase by $5. That's really the picture. So 21 students, the change is that we increase by 5. 22 students is the constant rate by 5. And we're gonna keep this up to the 30 students, extra 5, extra 5. So this is gonna be an absolute straight line right there. Okay, every 1 student, 5, another 1, another 5, another 1, another 5. So that's really a constant rate. And finally, after 30 students, what's gonna happen? So after 30 students, the school will pay how much, whatever this is, but then after that, it starts, which makes sense, it starts charging a little bit less. So now every 1 student, $3. Every 1, $3, $3. So that's really the graph. So it's sloping less because the slope here is less. So that's really my graph. It consists of 3 pieces. Between 0 and 20, we have a scenario. 20 and 30, a scenario. 30 and above, another scenario. Okay, now if I want to find a formula, I actually need a formula for 3 lines, L1, L2, and L3. Okay, so what's gonna be the formula? Let's do that. What is f of n? Equal 3 pieces, some are easier than others. Up to 20, I don't have an issue. It's 200. Okay, now I have another formula between 20 and 30. Okay, what's the formula between 20 and 30? Okay, it means basically I want to find what L2 is. What's the formula for L2? Okay, L2 is a line, right? So L2. Okay, what's the slope of the line L2? Do we know the slope? By looking at it. Back to you. This is L2. What's the slope of this line? Every unit, we go up by 5. Every unit, we go up by 5. Every unit, we go up by 5. Means the slope of this line is actually going to be 5. So L2, the slope is 5. Now, a point. What's the point? This is a point on L2. What are the coordinates of this point? It's 20 and 200. So the point is 20 and 200. So the equation is going to be y minus 200 is the slope times n minus 20. So the slope, the equation here is going to be 200 plus 5 times n minus 20. So if I am between here and here, my equation is going to be 200, which is really makes sense, plus 5 times n minus 20. And this is really makes sense because between 20 and 30, we're going to pay the flat fee or 500 and 5 for every extra student more than 20. So if I have 21 students, I pay $5. 22 students, I pay 2 times 5 extra. 19 student, no, not 19, 29 student, 29, it means I pay 5 times $9, $45 extra on the top of 200. And finally, if n is larger than 30, what's really happening here? For L3, every unit, we go up by 3. So for L3, the slope is 3. The point is this point right here. This point right here is 30, and then 200 plus 10 times 5. So it's 200 plus 10 times 5, because between 20 and 30, we have 10 students, 5 per each. So this point is 30 to 150. So the point is 30 to 150. So my equation become y minus equal 30 times, my apology, 3 times n minus 30. So my L2 will become 250, the cost for the first 30 student, plus for every student above 30, it's 3. And of the formula. Right? Was anybody able to get it? Okay, so go over this problem again, and if you have questions about it, please let me know. Either email me or ask me next time, because these are nice little problems that's really how piecewise really come up. Things are a physical quantity that we need to compute, but I don't have one formula. We have different formula depending on the value of my input. Any questions? All right, so please do your math lab questions. Don't forget about those. All right, today we're gonna move to section 2.4 called, okay, so section 2.4, and it's actually a rather simple section, new functions from old. So new functions from old. Okay, so, okay, a function for us is a rule. You give it an input x, and it's gonna spit out an f of x. And so suppose we have two functions, f and g. Two functions, means we have two rules. Okay, two rules. So we have two functions. It means we have one rule, f, and we have another one, g. Now, what's the idea of new functions from old? So we're going to create several functions using f and g. Okay, the first ones are easy. So we're going to define a new function. So we define the following. Sometimes you see something written like f plus g. What are they talking about? What's f plus g? F plus g is a function. It means it's a rule. that if I want to tell you what the rule does, I have to tell you what it does to every x. And it will do to every x what we think it should do. It's just take f of x and add to it g of x. As simple as that. So when you read f plus g, so you have two rules. That's the third one. What does this mean? That's the new function is just f of x plus g of x. So that's sum of function. And sometimes we see the following notation, fg. What does this mean? This means nothing more than f, the same function, whose output is f of x times g of x. So there are notations that mean the following. Okay. Then another notation is, sometimes you see f over g. What do they mean by that? So that's a rule. What does it do to x? It takes f of x divided by g of x. Okay, so that's the first set of new functions. So if I have two functions, I can add them according to this rule, multiply them according to that rule, and divide them according to this rule. But sometimes instead of writing f of x over g of x, a lot of books will write f over g at the point x, which would mean f of x over g of x. So let us practice very quickly this simple one. So for example, let us say I give you the following. Sorry. Right. So suppose you're given very simple one. So example. Suppose I tell you f of x equal x squared plus 2, nothing deeper than that. And I tell you g of x equal 5x plus 6, okay? And let us say I ask you to compute f plus g of 2, okay? The idea is that what does this notation mean? F plus g of 2, it means you compute the value of f at 2 and you add to it the value of g of 2. So that's a new function, f plus g. What it does to an input is the output of f plus the output of g. As simple as that. Okay. So what is f of 2 now? F of 2 is 2 squared plus 2. What's g of 2? Is 5 times 2 plus 6. And the rest we add them. That's a 6. That's a 16, which is 22. So that's really the meaning of this notation f plus g. So it's a rule. It takes 2 to that. Okay, let us compute f g of 2. It's like kind of confusing. So even if you write fg, but it's really here, you should imagine this is times g. So if they don't put the dot, I usually like to put the dot, means times g, it means multiplied by g. What does this mean? This means you take f of 2, you times it by g of 2. That's what this notation means. Okay, f of 2, we just computed it. It's a 6. You times it with g of 2, which we computed it now. It's 60. And then you just compute an answer. 6 times 6, 36. And then you get 96. So it's just a notation for a new function. Right? Now, suppose I give you, again, I'm working with the same functions. Okay. We practice the last one. What does f over g of 2 mean? It means f of 2 divided by g of 2, okay? Which is nothing more than 6 divided by 16. So we simplify a tiny bit. That's going to give me 3 over 8. All right? One more questions before we define another in new functions. So a simple question now. What is, suppose instead of telling you f plus g at 2, I tell you find a formula for f plus g for any x. What's f plus g of x? So this is nothing more than f of x, as simple as that, plus g of x. It means that's a new rule. f of x is x squared plus 2. So that's what this new function does to x. And g of x is 5x plus 6. So this would be nothing more than x squared plus 5x plus 8. Okay, that's the new function. Okay. So we can use old functions to combine them. And the way we can combine function is adding them, multiplying them, dividing them. Okay. There is one way we can also combine functions, which is usually it's important, and it's called the composition of two functions. So composition of two functions. Okay, so we added functions, we multiply them, we divide them, and now there is the idea of composition. What does it mean, composition of two functions? It means the following. Suppose we have two functions, f and g. It means two rules. Two functions. Okay, so we have those two rules. F has a rule, g has a rule. Then the composition of f and g, the composition of f and g that has a specific notation. So that's we're going to construct a new function denoted by f, a little circle here, g, so that's a new function, is defined by. Okay, so we're going to define a new function which called the composition of f and g, and the notation is f little circle g, f little circle g, and it's defined as follows. Very easy. F little circle g, that's a new function. What does it do to an input? It does the following. Takes the input and evaluate g of x. So I have, then I use g of x as the input of f, and I compute f of g of x. So in other words, f composed with g is the following. You start with an x. X, you have the function g, you compute g of x. So now you have another number. Then you take g of x and you compute f of g of x. So you use g of x as an input of f and you compute it. This is what we call this is what we call f composed with g. Okay, so you start with an x, you compute g of x. Now you use g of x as an input for f, and you compute f of this g of x. This new function has a name and it's called f composed with g, or the composition of f and g. Okay, so let us practice this definition. All right, so I'm going to start myself and then I will give you some worksheet and we're going to do it together. So example, how do we compute that? Okay, so example. I'm going to take two functions, f of x equal the square root of x. And g of x is x plus 2. And we are going to try to practice this definition, which is actually not very hard, as you will see in a second. Evaluate f composed with g of 2. F composed with g of 2. What does the definition tell me? This is equal to, you compute g of 2 first, and then you compute f of g of 2. So we start with 2, as simple as that. You compute g of 2, and we use g of 2 as an input for f, and you compute f of that. So to be able to compute f of, I have to compute g of 2. So let's see, what's g of 2 here? I do it on the side just to make sure that's what I'm doing. G of 2 is 2 plus 2. It's equal to 4. So f of g of 2 is actually f of g of 2 is 4. It is f of 4. Now what is f of 4? What does f do? It takes the square root, which is equal to 2. Okay, so we're going to do another one. Suppose I take g composed with f of 2. So I changed a little bit the scenario, not much. What's g composed with f of 2? Verbatim, the formula. What does it do? You take 2, you evaluate f at it. The order is very important. The order in which I'm writing my function is crucial here. So g composed with f. First you compute f of 2, and then you compute g of f of 2. Once you can write it like this, the rest should not be hard. Now let's compute that. What is f of 2? What does f do to 2? F, take the square root. So f of 2 on the side is actually the square root of 2. So now I need to compute g of the square root of 2. That's what my f of 2 is. Now what does g do? G takes x, the input, and add 2 to it. Okay, so that's how those function acts on every value of 2. Now I can ask you a general formula. So let us say my question is find a formula. Find a formula for f composed with g of x, or for f composed with g. What does it mean, find a formula? It means instead of telling me what f composed with g does to 2 or to 3, tell me what it does for any x. So it means I need to find f composed with g for any x, not only particular value like I did here. But again, that's the same idea. What's the definition? It's f of g of x. That's what f composed with g. It's you take x, compute g of x, use it as an input for f, and then compute f of it. All right. But what is g of x? What is g of x? G of x is x plus 2. It means now, wherever there is g of x, I have to put x plus 2, because that's what g of x is. Very good. Now what does f do? What f does to an input, let me remind you, f of x is the square root of x, because you don't see it. That's what f does. So what f does, it takes the square root of what you give it. And that's really the general formula for f composed with g. So f composed with g of x takes the square root of x plus 2. Okay, now I want the same thing, but for g composed with f. Okay, what's g composed with f of x? Remember, the order matter. Here is g of f of x. So this is x, we compute, and then it's g of it. Now, what does this do? What does f do? F takes the square root. So this is what f does. What g does, g takes your input and add 2 to it. So this is going to be the formula for g composed with f. Okay, so these are going to be very useful for you. Composition play a very important role eventually, especially if you guys go into calculus, but that's really how it is defined. Okay, now I want you to practice this. We're going to practice it together. I want you to go to Brightspace as usual, and I have a worksheet called worksheet number 8, composition of function. Please pull it up in front of you, and we're going to work on it together. Are you with me? Okay, so go to Brightspace, all of you. It's worksheet number 8. I am sure it is there, I think. I remember I put it there, and we're gonna work on it together. All right, let's get going. We can do as much as possible. Okay. All right, do you guys all have it? Yes, very good. So let us start with, let us start with A, B, C. And I would like to do the graphical one. So at some point we stop, I do the graphical one. But for now, let's get going. Okay, I'll give you 1 minute to do the first one, and then I will do it in front of you. So have a sheet of paper next to you, and that's you guys do them, and then I will correct them for you. So you have, you don't need more than a minute for the first one. So that's a sum. So we have to be very careful what we have. That's a sum. So we have to understand that's a sum. So when you guys start having answers, put them on chat, and then I will check with you, and we do it. Anybody? Okay, I'm starting to have answers. Anybody else? All of you should be able to do those. All right, I'll do it. I mean, first the definition. That's f of 5 plus g of 5. First the definition. Always we start with the definition. What does this new thing mean? What is f of 5? It means I plug in 5 for x. 5 minus 2, it's a 3. Plus g of 5. I plug in, so g of 5, I'll do it on the side. G of 5 is 2 times 5 plus 3. G of 5 is 13 plus 13. Okay, and as you guys know, I like you to always give your answer as one fraction. So now I have to find a common denominator. And the common denominator, obviously, it's a 3 in here. So I'm going to have 1 plus 3 times 13 over 3. Now 3 times 13 is 39, which is going to give me 40 over 3. Okay, so that's really how I would like you to do that. All right, B. I hope you guys will be a bit faster with B or get going. You have 2 minutes to do B. Now, I can't see you, but I trust you that you're going to do the work. Okay, why are you guys stuck? Where are we stuck? Are you with me up to here? This is f of x plus 2x plus 3. You're with me up to here. Now, I want them as one fraction because basically I want you to practice finding a common denominator. That's honestly what I want you to do. So what will be the common denominator here in this expression? What's the common denominator? It's x minus 2. That's the common denominator, x minus 2. So if you want to express this as one fraction, I have to find the common denominator, x minus 2. All right, so let's do that. So this is 1 over x minus 2 plus 2x times x minus 2 over x minus 2 plus 3 times x minus 2 over x minus 2. So if I'm asking you to find, express as one fraction, it means I am after you wanting you to find a common denominator. And now we have to combine the numerator and proceed. My common denominator here is x minus 2. Now let's combine the numerator. 1 plus 2x times x minus 2 plus 3 times x minus 2. Now what I'm going to do is combine like term and simplify as much as I can. That's going to give me 1 plus 2x squared minus 4x, I'm distributing, plus 3x minus 6. Okay. So now let's combine. I will have 2x squared, then minus 4 plus 3, it's a minus x. 1 minus 6, I went ahead of myself, is minus 5. Okay, that's what I mean as one fraction. It means those are not numbers here because I have an x in here. So my common denominator will have to be x minus 2. Okay. All right. C, fg of 5. What do we mean by fg of 5? What's really meant here? Fg, this means times 5 times g. That's really what it means. Okay, so if I don't put anything in between, usually some books will put a dot, but I think this book is not putting a dot, it's putting fg. What I mean by that is f times g. So the definition of that is f of 5 times, you multiply it by, but that's okay, don't worry about it, times g of 5. Okay, so let's do that. What is f of 5? F of 5. F of 5. F of 5 is, f of 5, we just computed it. I think it's 1 over 3 times g of 5. G of 5 is 13. So 1 over 3 times 13, it means 13 over 3. Okay? Right. Fg of x. First, what it means. That's crucial. First, what those things mean. It means you take f of x, you multiply it with g of x. That's really what it means. Very good. What is f of x now? What does f do? It's 1 over x minus 2. So that's simple. G of x means you multiply it by 2x plus 3. And now we use a property. How to multiply fraction is 2x plus 3 over x minus 2. Okay. Right. Now it is your turn. I'm not interfering this time. I want f composed with g of 2. I want you to do it. I want G composed with F and this. Okay, so we start with the first, but this time I want a lot of answers. I want to make sure you understood the composition of two functions. So get going. And I want a lot of answers on chat. I don't want only one or two. When you find it, you tell me what it is. Okay, I still have one answer for the first one. I want more than one. Okay, I'm having different answers. So I want more, and then we settle the question. I don't know which one is right. I'll do it with you. Okay, I'm having a third. Anybody else? Very good. So I'm having, that's interesting. All right, let's redo it. First, the definition. Definition, no way out. What's the definition of F composed with G? Unless you know the definition, we are at a loss. It's F of G of 2. Okay, that's the definition. It's F of G of 2. So now how do we compute this? First, we need G of 2. So I go to the side just to, and I find, okay, what is G of 2? What does G do? It takes 2 times 2, 2x, plus 3. 4 plus 3, 7. So this is what G of 2 is. Then I have to evaluate F at G of 2, F of 7. Now what does F do? F, you guys have the paper now in front of you, is 1 over x minus 2. It means 1 over 5. All right? So 1 over 5 was the correct answers, and I know that I had 2 different ones. All right, now I want you to do F. And again, you put the answers on chat, and then we proceed. And as you guys do it, I'm doing it, because I didn't do those. Okay, I have 1 answers. I want others, because you have to do mistakes to learn. Okay, I have 2. I want more. Please, I want each one of you to feel responsible for answering. Okay, I want more than 2 answers. Hurry up, there is a problem. I want to make sure I do it. So I want more answers. Okay, all right, that's better. So let's do it. Okay, definitions. That's what I believe in. It's G of F of 5. If you don't start like this, you're lost. So first I compute F of 5. So I'll go to the side and I evaluate F of 5. So F of 5 is, what does F do? It's 1 over whatever you give it, and then take away 2. Means 1 over 3. Okay, so it's going to be equal to G of 1/3. But what does G do? It takes 2 times what you give it, and then add 3 to it. That's 2 times 1/3 is 2/3. Plus 3. Now, because I want you to express your answer as 1 fraction, I actually want you to be able to find a common denominator. That's a common denominator of 3. So that's 2 over 3 plus, I have to multiply this by 3, 9 over 3, giving me 11 over 3. Okay. Very good. Now, here I wanted you to compute f compose g as a particular value of particular input too. Now I want you to do it for any x. Okay, and see what you get. What's f compose g for any x, not the particular one. Start with the formula and build up. Okay, anybody else? Okay. All right. Okay, so let's do it. Definition, as usual. It's f of g of x. Okay. It means f of what? What is g of x? What does g do? G takes the input, multiplied it by 2, and then add 3 to it. That's what f does, what g does. So this is so far g of x. Okay. Now what does f do? F is 1 over the following. Whatever you give it, and take 2 away. But this time you're giving to it 2x plus 3. So that's going to be 2x plus 3 minus 2. That's what f does. So now I just collect my, just simplify. 2x plus 3 minus 2 plus 3 minus 2 is plus 1. Which can give me 1 over 2x plus 1. Okay? Right. Shall we turn the page? Okay. Now, the rest is verbatim the same. The rest is really verbatim the same. Nothing really more than that. So I'm going to do J, and then I'm going to look at the one which is graphical because it's important. So now I want you all to do J, see how well you do with that. So it's f composed with f of t. And here I remind you what f of x is. That's f of x. And I remind you with g, so you will have them in front of you. It's 2x, sorry, plus 3. Okay, so this is my f and g, and now I want to compute f composed with f of t. Don't let t get to you. I'm calling my variable t because I can call it whatever I want. So that's a bit harder. Ooh. Okay. Yeah, that's, I think. Now, can we simplify that? So, first definition is f of t. And if I use t for variable, I really want you to use t as variable. You have to get used that x is not the only name we give a variable. It's important for you. So f of t. So this is, what is f of t? It's f of 1 over t minus 2. That's what my f of t is. So that's f of t. I'm going to put it right there. That's what it is. All right, this is equal to what? Now, here's the thing. What does f do? It's 1 over whatever you give it and takes 2 away from it. Whatever you give it, whatever you put in it. If I put 1 over t minus 2, I have to put 1 over t minus 2. Okay, so we use t because it's t. It's not that. Okay, all right. This one, I want all of you to simplify it for next time because I would like to work on number 2, but I want you to really simplify for next time and see how well you can simplify it. So how can you make it look nicer? Because I don't really like this messed up denominator. I want you to see if you guys can fix it for me, and next time I will take your answers. The idea is find a common denominator here and let this expression look a little bit better than that. Okay, so for next time, on the top of your homework, I want you to simplify that. And the reason is I want to discuss with you number 2 and before we let go. All right, number 2. This time I'm thinking graphically. Instead of giving you a formula for f and a formula for g, I'm giving you the graph of f and the graph of g. Okay, and then this is my question. Find g composed with f of 1. So definition verbatim, it means I need to find g of f of 1. That's what this means. Very good. Now, what is f of 1? You all have the graph and you all can see very well. What is f of 1 according to the graph? F. So f is the line. G is this function that's going up and down, which is, if some of you know it, that's the graph of the sine function. But to have this oscillating function, so f of 1. So I'm having one answer. If this is 5, 1, 1, so this is 1. And I want f of 1. F is the line. So from here, I have to go down up here. So according to my graph, this is minus 4. So f of 1 is minus 4. Now, what I want is a g of that. So now I already found f of 1, which is, so now I need g of minus 4. Back to my graph. Okay, what's minus 4? 1, 2, 3, 4, that's minus 4. And I want a g. G is the oscillating one. It's, honest to goodness, is 0. Okay, now do the second one the way I did that, step by step, word by word, and see what you guys get. Okay, the second one. Okay, I'm starting to have answers. Let's see. Again, very slowly. It's f of g of 2. So first I have to compute g of 2, and then I have to compute, yeah, you guys are fine. Compute f. So what's g of 2? That's what I need first. Okay, 2 is 2. G of 2 is 0. So it means I need to find f of 0. All right, what is 0? 0 is right here. F of 0 is there. F of 0 is minus 2. For those who got minus 2, you're on the right track. Okay, C. Okay, I have one answer, so I would like would like more. I had 2 different answers, so I would like more. I have 3 different answers. So I need to settle, okay? All right, I'll do that, then of course we have to finish. So it's f of 0. Very good. What is f of 0? This is 0, okay? So f of 0 is right there, -2. That's f of 0. And then I need f of -2. All right, I go back. -2 is right here. That's -2. What is f of -2? I have to go up till I hit the graph, right there. What's this here? This is a. So the answer is 2. I got a lot of them. So the answer is actually a 2. Okay? And time is up. For next time, you guys do the homework that I will assign, you will have a quiz which will cover what I did today, as well as piecewise defined functions, and the online homework, which I don't think should be hard, the online homework. So please do it. It's due on Thursday, so you will have plenty of time, but don't wait for the last minute. A lot of you wait for the last minute and they get stumbled at the last minute and they don't do it. So please get going, all right? Any questions? So it's due Thursday evening because of the delay last week for the fall break. All right, good luck.